This Zoom session is being brought to you by the fractal inverse bullseye horizon. All right, now for today, you'll be getting on to the dot product. And we have a curious problem as of, let's see, Wednesday we'll be at 5-6. I have written up here 5-6 and 5-7, and that's really about the edge of the material that we were scheduled to cover, because I mistakenly did two sections a night for a while, so we're way ahead of schedule. But we won't be finishing right before the spring break, which is a pity. Perhaps we'll discuss this on Wednesday. Perhaps I can open up the like. Do I have a quiz too? Right out, and the quiz and the final. That way we could have it all done fairly early. Well, I do already have quiz 2 out, but I could open up the final for you to work on over the spring break. We'll discuss that on Wednesday, okay? So, but even though there'll be one section left over, so be it. And I suppose there'll be a couple other sections I could arrange as extra credit after the break. Well, and lots of other in effect office hours, so be it. Today, we're going on to the dot product. The dot product given two vectors. The dot product of v dot w is a number, so it turns vectors into numbers. A bit odd. It yields a different kind of object than the original thing. Anyhow, it's given two vectors with components v1 and 2, w1 and w2, their lengths and the angle between them. There are two definitions, one geometric and one algebraic. The algebraic definition is that the dot product is v1 times w1 plus v2 times w2. You multiply corresponding components and add the result. The geometric definition of the v dot w is the length of v times the length of w times the cosine of the angle between them. Now, okay, this is called a product, and partly and in many cases, mathematicians invent something. I'll call it something that gives it an old name, like product. And mostly because it has many of the same laws as the old thing. So this has laws like products. It's commutative. V dot w equals w dot v. V dot the zero vector, 0 by 0, is 0. A vector dotted with itself is its length squared. That's because theta would then be 0 and cosine of 0 is 1. So you get length of v squared. You have a kind of associativity, k times v dot w equals k times v dot w. Okay. And you have a kind of distribution, u dot v plus w equals u dot v plus u dot w. These are vector, this is a vector sum, this is the dot product, this is a scalar sum. I dot I, that's the vector in the positive x direction, is 1. J dot j, vector in the y direction, is 1. And I dot j, vectors that perpendicular, are 0. In fact, if two vectors are perpendicular, then theta is 90 degrees and cosine theta is 0. So dot product equaling 0 is a good way to find out whether prove that two vectors are at right angles. In fact, if you go through from here and you solve for theta, so you divide by the lengths, length v, length w, and take arc cosine, then the angle between two vectors is the arc cosine of their dot product divided by the products of the lengths. The vectors are at right angles, called orthogonal, if their dot product is 0, because if this is 0, then we arc cosine of 0, which is 90 degrees. So here's some examples. Here's a vector 2i plus j. Here's a vector I minus 2j. What's their dot product? What's the angle between them? All right. In terms of components, v is 2 by 1, as we see here. W is 1 by negative 2, as we see here. And all right, take the dot product. 2 times 1 plus 1 times negative 2 is 2 minus 2 is 0. Okay. So theta is arc cosine of 0 of the length, which is arc cosine of 0, which is 90 degrees. These vectors are at right angles. They're orthogonal. Well, then, now let's try this. 3i plus 4j minus 6i minus 8j. 3 by 4, negative 6 by negative 8. What's their dot product? What's the angle between them? All right. 3 times negative 6 plus 4 times negative 8 is negative 18 minus 32 is negative 50. Length of V, square root of 3 squared plus 4 squared comes up to 5. Length of the W is square root of negative 6 squared plus negative 8 squared comes out to 10. And so the theta is the arc cosine of the dot product of the lengths. The dot product is negative 50. The lengths are 5 and 10. So you get arc cosine of negative 1, which is 180 degrees. They are in the opposite direction. Sorry, like that. They are in opposite directions. That's called anti-parallel. Now, find number A such that V equals I minus AG and W equals 2I plus 3J are orthogonal at right angles. All right. Vectors are orthogonal if their dot product is 0. V is 1 by negative A, W is 2 by 3. So you want 1 by negative A dot 2 by 3 equals 0. 1 times 2 is 2, minus 8 times 3 is minus 3a. So 2 minus 3a equals 0. Transpose the 3a, divide by 3. A equals 2/3. So let's solve this. Now, all right, here's a concept from physics. Work is if you have a force on something and bring it, and it moves, that force moves, and it moves along a certain displacement d. So here's the force on the object, here's the displacement. Then the force exerted along that displacement does work. It's a form of energy, equals F dot D. So for example, if the force and the displacement are in the same direction, then the dot product is positive and it's a positive work. If they're in opposite directions, then the force and the it's pushing against the displacement, so the work is negative. And if they're at right angles, then the force does no work in the direction D. So for example, if something is displaced from 0, 0 to 6, 0 with a constant force of 3 pounds at 60 degree angle of 60 degrees, what's the work? All right, well, the force is 3 cos 60 by 3 sine 60, and that's 1.5 by 3.3 over 2. The displacement is 6 minus 0 by 0 minus 0 is 6 by 0. All right, so the work is this dot this 1.5 3 over 2 but, plus by 3 root 3 over 2 times 0 comes up to 9 foot-pounds. Now you can also figure, let's see, that is force, this length is 3 pounds, this is a distance of 6, and 3 times 6 times cosine of 60 degrees. Well, 3 times 6 is 18, cosine 60 is 1/2, so half of 18 is 9. So we get the same result, 9 foot-pounds. Here we have my way of drawing a picture of a car, not very good. A van, I suppose. It's parked along a sloped street, sloped at 8 degrees. Its total weight is 5,000 pounds. What is its force along the pavement? What is its force perpendicular into the pavement? Well, this one we don't really need dot products. We just need a bit of basic trigonometry, right angle trig. We draw this right angle triangle. Here's the force along the pavement. Here's the force into the pavement. Here's the total force at 5,300 pounds. Here's an angle of 8 degrees. So A over 5,300 is sine of 8 degrees. So A equals 5,300 sine 8 degrees. B over 5,300 is cosine 8 degrees. So B equals 5,300 pounds times cosine 8 degrees. So it's 737.6 pounds of force along the pavement and 5,248.4 pounds into the pavement. Okay, I think that concludes that.